is renewable. A lot of that energy is stranded and therefore is very inexpensive and is perfect for Bitcoin mining. So I'm going to talk a little bit about renewable energy, different alternatives that exist, and then also talk about what we believe is a very promising fuel source for the future. Safe harbor statement, all public companies have to put this up there, so no need to read it unless you're planning on trading in the stock immediately afterwards. So Bitcoin mining, as I said, is becoming increasingly more sustainable. If you go back to Q1 of 21, before the transition from China, most of the energy mix was fossil fuel, high carbon producing. So roughly the renewable mix was only about, or the sustainable mix was about 36%. It then quickly jumped to 56%. And as you can see, quarter by quarter, we're continuing to increase the sustainable mix of energy. Very few industries can convert from heavy fossil fuel, heavy polluting fuel sources to sustainable sources as quickly as the Bitcoin mining industry. And this is something I'm very proud to say Marathon has been very proactive in. When we initially were mining at a facility that was powered by a coal-fired plant, albeit a very clean one, but it was still a coal-fired plant. Today, we have no mining operations at any fossil fuel plants, and all our operations are behind the meter at wind farms, predominantly in West Texas today. So Bitcoin miners have focused on solar and wind, and those of you who are familiar with this concept called the duck curve, it has to do with how energy is used during the day. Imagine a silhouette of a duck, the tail over here, then the belly of the duck, and then the nib, if you would, and neck. Renewable energy is available in the form of solar, typically from 9 a.m. to 3 p.m. Wind energy is more typically available in the afternoons. Peak energy consumption is between 4 p.m. and 9 p.m., which means that solar energy does very little to contribute to the energy available for peak energy load. But you also have to look at how energy is used on the grid. At the bottom is nuclear. Nuclear is not a very variable fuel source. You turn it on and it has to run. So it's what's called base load. Above nuclear comes coal typically, because it has a similar characteristic. You can't turn coal on and off very easily. Then you add natural gas. Natural gas can be turned on and off and is a great variable load source. And so you think about the base of the energy pyramid is nuclear, then coal, then natural gas. Only then do you get solar and wind energy, which are interruptible, meaning this is the energy that the grid turns off first and foremost when they don't need it. Again, remember, peak energy is 4 p.m. to 9 p.m., middle of the day, low energy need. In the morning, a little bit of energy need. So what ends up happening is there is a ton of solar energy that gets curtailed in the U.S., for example, which means shut down because it's not needed. There are even times in Texas where energy pricing can be negative, meaning there are energy providers who will pay you to take energy. This is very different than the model in Europe where you have an energy shortage going on. In the U.S., you have true excess energy. And the only incentive for renewable energy developers to build more renewable energy is if they have customers. And to have customers in the traditional model, they have to have transmission lines, which means they have to have distribution of that energy. People will not build transmission lines to new renewable sites unless the transmission lines are connected to consumers. And the problem is there is lots and lots of renewable energy that has been built in the U.S. that is so far from consumers that they can't sell most of the energy they make. And that is a perfect place for Bitcoin miners to operate. So why is this a perfect place? So let's talk about how solar and wind pose unique challenges. So for the first thing, wind energy and solar is interruptible. So if they can only sell their energy, let's say 10% of the day, then they have to charge the grid very high prices in order to get a good ROI on their sites, on their development projects. If they had a baseload customer, like a Bitcoin miner, who sits behind the meter, can consume all the excess energy, that lowers the break-even point, essentially, for that power plant when they sell energy to the grid, and so it makes them more economically viable and lets them operate longer. Bitcoin miners can consume the stranded energy and can deal with the intermittent nature of that power. Why? Because Bitcoin miners can shut down their systems in 10 minutes. You can't do that with an aluminum smelter. You can't do it with a car manufacturing plant. You can't do it with food processing. You can only do it with something like high-performance computing or Bitcoin miners. And then when energy is available again, you can turn them right back on, and within half an hour, they're up and running. So the deal between the Bitcoin miners and the energy companies is, I'll soak up that excess energy if you give it to me at a low price. And so they're willing to negotiate very attractive prices to Bitcoin miners. From an ESG perspective, the benefit is that this is a renewable energy source. It's wind, it's solar, could be geothermal, could be other forms. And so that gives miners the ability to truly operate with renewable energy. For the operator of the power plant, it gives them the opportunity to have improved profits as well. But there are other underutilized and untapped opportunities, not just solar and wind. If you look about the energy mix today, wind and solar represent only about a quarter of the clean energy generation mix. Hydro is 40%, nuclear is 26%, wind, solar, then biomass, bioenergy, and then you have other forms beyond that. So let's talk about nuclear. Nuclear is technically sustainable energy. People would argue, is it green or is it not? I'm not going to go into that discussion. But nuclear is a form of energy that is sustainable and is broadly available in many markets today. The problem is it's hugely expensive to build, very hard to get licensed, and it's very regulated. And at the end of the day, all of those things add up to make it very expensive energy, actually. Geothermal energy is available in certain places in the world where you can drill down, essentially tap the heat from the magma layer of Earth and create steam, which then fires a steam-fired generator. Problem with geothermal is, at scale, it's still quite expensive to operate. And there's a lot of maintenance related to it. Tidal energy, this is essentially using wave energy. Again, very costly, very hard to have large-scale, utility-scale plants of this. So, what about bio-waste? Most people don't think about bio-waste as a true fuel source for 30 megawatts, 50 megawatts, 100 megawatts. But there are huge landfills full of garbage that today are emitting methane. Just like the flare gas you have in oil fields, there's a type of methane that comes out of material that's rotting in the ground. You could also think about dairy farms that produce huge amounts of cow manure. Anything that generates methane can be used as fuel. The problem is most of these facilities aren't connected to the grid because the grid doesn't want to connect to them. And they've historically been expensive to use for energy generation because the traditional model has been to use methane from these sites, refine it enough so it can be put into an LPG gas line. But imagine if you could burn that methane at source without having to enrich it or refine it in any way. And that technology is now available. And we believe that there's a great opportunity for Bitcoin miners to actually mine at biofuel sites at utility scale with energy that's available 24/7, 365. On the one hand, you're taking methane, which is 75 times more of a climate disaster than carbon dioxide, and converting it to carbon dioxide. That's a huge saving for the planet right there. The other benefit is you're creating more energy generation. So as the electrification of the economies in the US, Europe, and other places happen, you're creating more sources of energy. I don't know how many of you maybe read recently, but Bloomberg said that electrification of long-distance transport trucks, semi-trailers in the US, lorries in the UK, will require that charging stations have access to 35 to 50 megawatts of power per charging station. This is like a small town. Where are they going to get the energy from? People aren't going to build power plants next to recharging stations. So we're going to need new types of microgrid energy production, like biofuel, like solar, like wind, etc., which are really going to drive these things. So convert bio-waste into Bitcoin, we think is an interesting strategy and should be followed. The other benefit to electrical generation using biofuel is that you can earn renewable energy credits, which when sold can actually subsidize your cost of energy, lowering your cost of energy and making that a very attractive source. You're off-grid, you're not parasitic to the grid, and you're in a very symbiotic relationship with the environment. So with that,